Your 4 solvents will come in 4 small vials. To test for odors, I'm recommending you take the lid off and first try to smell the cap itself. If you can get an odor from that, then you're done. If you can't get a smell from the cap, then you can get your nose fairly close to the vial and waft until you say, yeah, I smell that. It may be hard for you to describe the odor, but what you're really trying to do is to say, well, if I smell that again, I'll know that smells like hexane, or that smells like ethyl acetate. So learn these scents and try to remember them so that when you encounter them again, you can say, I recognize that smell. Every ACR station has a molecular model kit with which you can build representations of your organic solvent molecules. Color code is inside in case you've forgotten. Unlike your sophomore kit, this one has different bond lengths. If you want your molecule to be realistic, you can use this guide here that tells you which peg represents an OH bond or a CH bond, etc. When you're pipetting organic solvents, it is common for the liquid in the pipette tip to simply drip out. The organic solvent has limited hydrogen bonding, and there's a high vapor pressure that can push the liquid out. So to solve this problem, you pipette up and down and up and down, and you should reach a point where you can pipette and the liquid no longer drips out the bottom. So I call this conditioning the pipette tip. It'll allow you to pipette organic solvents fairly accurately. You're going to put 200 microliters of organic solvent in an Epidorf tube. You can measure 200 with a P1000. Remember, that's 200 microliters, not 20. When using the P200, I will ask you to do 100 twice rather than 200 all at once. If you draw up 200 all at once, the liquid gets dangerously close to the plastic part of the actual pipetter, and you want to avoid contact. If, on the other hand, you do 100, there'll be a nice safe distance between the level of the liquid and the pipetter body. So this is a safer way to do it until you are certain you have enough skill to pipette 200 microliters all at once. To collect data fairly quickly, each individual will need to say, okay, the empty tube had a mass. It'll always be around 1 gram, but individual tubes may vary a little bit. So if you know the mass of the empty tube, then you can put 200 microliters in the tube and weigh it again. Use the difference to find out the mass of the fluid. So here I've added 200 microliters of organic solvent. Throw that on the scale. And I can use subtraction to figure out the mass of the solvent itself. If you're using an open pan balance, air currents will make a difference. So be careful. If you need greater precision, that's when you use the analytical balance or the milligram balance that has the draft shields. There are 4 solvents, so if each student plans to do 4 trials, 1 with each solvent, you should be able to get some reasonable data as well as gain some skill pipetting for every member of your group in a timely fashion. So P1000 pipetteman you already have in your drawer. Pick up a P200 from the rack in the research room. so that you can be multitasking instead of waiting in line. At the end of the hour, you can dispose of your little bits of solvent in the appropriate vessel. This one here with the green is for dichloromethane waste, and this is for general organic solvents like ethanol, ethyl acetate, etc. So here, dump the contents. The tube itself is throw away in the trash. Put the lid back on. There we go.